In this video, we are going to look at question 28 from the specimen paper.
In this question, we have a loudspeaker cone which produces a pressure wave. There is a sound wave in air, and it does so by oscillating from a point here to a point 5 millimeters further every 0.2 milliseconds. We are supposed to say which of the following four statements can be deduced from this: that the speed is 25 meters per second, that the amplitude is 5 millimeters, that the wavelength is 5.5 millimeters, or that the frequency is 5 kilohertz. First of all, let's look at these four quantities and what we can say about them just from these two pieces of information. So the period of the motion, or of the oscillation, is definitely 0.2 milliseconds. And the frequency must be 1 over that. Now, how about the speed? What do you think the speed of this wave will be? The speed is simply given by the properties of the gas in which we are, which in our case is air, and therefore the speed will be approximately 300 meters per second, but that doesn't depend at all on the setup drawn in the diagram. Combining the speed and the period, we also get the wavelength, which is approximately 6 centimeters. With these four quantities at hand, it is easy for us to rule out P and R straight away, because they are in contradiction with what we have found. Part Q I found very tricky personally, especially in the time pressure of the exam. It is very easy to make this mistake and just look at the diagram, 5 millimeters. Well, the amplitude really looks like it will be 5 millimeters, but don't forget that this is a sound wave, not simply a wave on a string. It's a wave in pressure which spreads through the air. So if there is some amplitude associated with it at all, it must be in pressure, not in units of distance. And so even Q is wrong. And S remains as the only correct one because the frequency 1 over 0.2 milliseconds equals 5,000 hertz. So S is correct. And S being correct was option B.